Greetings and hello, this is Mrs. Gillihan, and we are looking at task 1.5, and this is part of your set homework assignment. And in this assignment, you are being asked to find some recursive and explicit formulas for a geometric sequence, and this is one of the first formal opportunities that we have to do this. So let's tackle problem number 5 together. Let's read the directions first. Below, you are given various types of information. Write the recursive and explicit functions for each geometric sequence. Finally, graph each sequence and make sure you clearly label your axes. And let's start there with the axes. We have to be very careful. One of the things I've noticed on homework and quizzes is that sometimes students are still getting mixed up as to what goes where. And there is a correct location for both your independent variable and your dependent variable, and it is very important to realize that the term number is the independent variable and will go on the x-axis. So term number 1, term number 2, term number 3, term number 4. So that goes on the x-axis. On the y-axis is the term value, because the term number will determine the term value. So on the y-axis is our dependent variable, and that will be 2, 4, 8, and 16. So we have two pieces of information, both the term number and the term value, and it is very important to keep those separate. So in this particular geometric sequence, we see that our starting term, term number 1, the value is 2. And as we look at the pattern that occurs from 2 to 4, from 4 to 8, and from 8 to 16, we see that the common ratio, or the number that is being repeatedly multiplied here, is 2. And so let's take a moment to apply this and see what it would look like. I just happened to graph first. And so this is what my graph looks like as I get started. Ignore this for just a moment. I chose to label my x value, of course, with the term number. So term number 1, term number 2, term number 3, and term number 4. And that is not explicitly given here, but we do have to recognize that that is term number and is our important x-axis independent variable. And over here, another tip that I want to make sure I give you here is that you need to keep your scale constant. Another thing that I have seen on homework is that students simply take the 2, the 4, the 8, and the 16 and put a couple of tick marks here, evenly spaced, and then plot a point. And that is absolutely not going to show you the growth that occurs in a geometric sequence. So I chose to go by 5s here on my y-axis, 5, 10, 15, 20. And when you do that, you can very easily see when those points are plotted. And I did choose to plot the 5th term as well, which if I took 16 times 2, I would get 32. So the 5th term would be valued at 32. So we can see just how quickly our numbers start to grow when we plot these accurately on a graph. So it is very important that you choose accurate scale for both the x and the y-axis, and that your independent and your dependent variables are properly labeled. Alrighty, so the second part of this is to write your formulas. And so let's take a look at the recursive formula. Please remember that every recursive formula has two pieces. First, the f of 1 means, okay, what's the first number in the sequence? That's what the 1 means. And so you have to very deliberately state the very first number in the sequence equals 2. Okay? The second part of a recursive sequence says, well, once you have that first term, how do you find any other term? Okay, and we are considering that n. So if I'm looking for n, over here, this part, that equals f of n minus 1. So if you have a term, you need to go look at the term before it. And once you have the term before that term, then you would multiply by 2. So that's what this part is saying, is it's very deliberately simply saying, well, we start out with 2, and every number along the way gets multiplied by 2. All right, the recursive function or the recursive equation is very often, if you're looking for a number in the sequence way down the way, like the 20th number, it is not very helpful. It's only helpful if you know just the previous term already. The second equation that you are being asked to write is the explicit equation, which is a little more valuable to us on certain occasions. And this is simply both the starting number and the common ratio appear in this one single equation. So it's a little more straightforward. And so we have f of n equals 2 happens to be the starting point, f of 1. Okay, that's how we have labeled it. So if I look up here, the 2 is the starting number. That's what goes first. And then from there, we can see that we repeatedly multiply by 2. So when we repeatedly multiply by 2, that's this r value, the common ratio. And in order to tell us how many times to repeatedly multiply by 2, we use n minus 1 as an exponent. And we are working on that in class. For now, we're just going to leave that as our label and continue to work with that in class in order to help us find, perhaps we're looking for the 20th term or the 50th term. We would use that to help us do that. Alrighty, so on your homework, a couple of tips. Make sure that you memorize those recursive and explicit formats. They come in very valuable if we have a conceptual understanding of what is going on with the equations. Makes it much more easy to memorize these.